ভুলে গেছি হ্যাঁ আচ্ছা সমস্যা নাই so this is the question and this is the graph. Oops, no, not index that this is the graph. uh, Drawing the polarity graph is pretty simple. For the Strontium-90 graph, you have to finish the graph somewhere above the 12 division, because it would require 28 years to finish this up to half value, but 28 years is not available on the graph. So the remaining amount after 20 years for Strontium-90 should be uh, less than 12 division drop. So you have to finish this graph somewhere above 12 division. You can pick 1 division or 2 division more, but don't take too much, because that would be not accurate. Did they ask us to label these graphs? It's very important to have a look. They did not. So you don't have to label this thing, but always be careful to watch out in your question that did they ask you to label this. If they ask you to label this, there are exclusive marks for proper labeling. So since they did not ask us to label this, so we don't have to label this. So that goes on.
Sir, are there any marks for scale and base fit line? I mean, smooth line.
Yeah, definitely. Have a look here. We have 3 marks over here. So appropriate plotting for all this individual time frame gives you 1 mark. The quality of your base fit line gives you the 2nd mark. So this number 1 question has 2 marks in it, and the sketch graph of this one has 1 mark. The answer is yes. Drawing a good line has marks in it.
And sir, sometimes we have to, I mean, skip a point to make a graph smooth. Is there any marks for that?
Yeah, definitely. For example, if you are trying to plot a graph for paper 4, in some cases, you might actually have to skip a point or skip to more than 1 point to make the base fit line. The idea for base fit line is that you have to show a graphical average of all those points, which means you have to draw an about halfway line that has equal distribution of all the plotted points on both sides. The base fit line doesn't have to go through all the points, but it has to represent a graphical halfway value for all the points involved.
Thank you, sir.
Sure. B-তে বলছে the related place here is social count is in middle place become a social count one may have আচ্ছা এইগুলো তোমরা ট্রাই করলে পারবা, না পারলে আমি পরে দেখাবো। আমি জাস্ট এক্সক্লুসিভ কিছু প্রবলেম আছে যেগুলো আমি করে দেখাতে যাচ্ছি। আচ্ছা E equals to MC square তোমাদের সিলেবাসে নাই, এটা অনেক পুরান কোশ্চেন। So if you don't want to do E equals to MC square, you don't have to bother this, but you can essentially try and calculate. It's a very simple calculation. এখন এই মুহূর্তে তোমাদের সিলেবাসে E equals to MC square calculation বাদ দিছে। Let's try to fill up this equation. Have a look. 16. One radioactive isotope of iodine is iodine 131. As the nucleus of this isotope decays, it emits a beta particle, a symbol beta, and it becomes a nucleus of an isotope xenon, symbol xenon, Xe. Complete the equation in nucleate form for this decay. So এটা fill up করার জন্য আগে আমাদের বেটা পার্টিকেলের ভ্যালুগুলো জানা লাগবে। বেটা পার্টিকেলের ভ্যালুগুলো কি কি? বেটা পার্টিকেল
Sir, 0 or -1.
0 আর -1, তার মানে জেননের এই নাম্বারটা হবে কত?
Sir, 52.
নো, এটা তো -1।
54 134
এটা হবে 54 আর এটা 131 131 ই থাকবে। গুড। এটার বেন্ডিং কোন দিকে হবে? চিন্তা ভাবনা করো। ফ্রেঞ্চ লেফট রুল অ্যাপ্লাই করে বলো আমাকে যে বেন্ডিং কোন দিকে আসতে হবে।
Sir, নর্থ থেকে সাউথ একটু বলে দেন।
নিচে যাবে,
পড়ো, লেখা আছে তো, ম্যাগনেটিক ফিল্ড ইনটু দ্য পেজ বলে দাও।
স্যার নিচে যাবে,
স্যার উপরের দিকে স্যার।
নিচে
বেটা পার্টিকেলস উড
নিচের দিকে
ডাউনওয়ার্ড
দিকে,
স্যার নিচের দিকে
Downwards, sir.
ডাউনওয়ার্ডস।
বেটা পার্টিকেলস আর নেগেটিভ পার্টিকেলস। বেটা পার্টিকেল যেদিক থেকে আসতেছে কনভেনশনাল কারেন্ট তো তার উল্টা দিকে। সো ইউ আর গোনা
স্যার উপরে
হবে
স্যার নিচের দিকে, কারণ কানেক্টের ইলেকট্রন তো অপোজিট স্যার।
aim your middle finger. First define your left hand, not right hand. Take your left hand, aim the index finger into the screen, and then align your middle finger aiming to the left, because beta particles are coming from the left, which means conventional current should be happening to the left. Beta particles are coming from the left, they're going to the right. Beta particles are going right, so conventional current to the left. So if you do that, you'll find out the thumb is representing downwards. Can everybody get that?
Yes.
Yes sir.
ঠিক আছে। আর যেহেতু এটা একটা ম্যাগনেটিক ফিল্ড, সো এখানে বেটা পার্টিকেলের কার্ভটা হবে হচ্ছে সার্কুলার। আর সার্কুলার কার্ভ ইফেক্টিভলি আঁকার একটা ভালো বুদ্ধি আছে, ভালো বুদ্ধিটা বা সহজ একটা বুদ্ধি আছে, সেই সহজ বুদ্ধিটা আমি দেখাই দিচ্ছি। সেটা হচ্ছে You want to make the gamma ray go in a straight line. Drawing a straight line is pretty straightforward. You just extend this line in a straight line, which is perfectly good, and you can label this as gamma. আচ্ছা যাই হোক, মনে করে এটা straight line. You can label this as gamma, and beta particles are going to take a turn, and in a magnetic field the rotation of the or the bending of the charged particle is circular. So you can choose any, so a circular bend শুরু হবে এখান থেকে. So one of the easy way to draw this curve without drawing freehand is to choose any point as a center down this line. So মনে করো হচ্ছে এটা হচ্ছে আমাদের vertical line. আমি যদি এই পয়েন্টটাকে কম্পাসের সেন্টার ধরে এখানে একটা পারফেক্ট আর্ক আঁকি, সেটা আমার হয়ে যাবে. For example, if I draw an arc of this shape, ঠিক আছে, quarter circle. If you want to fill up this entire space, then one thing that you can always do is about assume the extension of this line, try to visualize this border and place your compass needle somewhere over here, and you can also draw a perfect arc from here. I might be able to do this. Can I? Okay, I'm trying to draw half of an arc. So yeah, maybe I can draw a circular path like this. What is pretty important that in your drawing, this pathway that you are drawing should at least appear to be circular. Now, making it appear to be circular is pretty difficult if you don't know how to compare to. So that's why I'm recommending the use of a compass. So choose any of the center point on this vertical line, either at the very corner or somewhere below. You can put it anywhere on your question paper, doesn't matter, and then draw a smooth curve, and then you finish your graph over here, which means you're not going to draw this entire circle. You're only going to draw the part that is within the hash line. So you forget about this and forget about this. Everything over here is non-existence. So you're only going to draw this part, and prefer to label this as well. This is the beta. বুঝা গেছে কি বলছে?
Yes, sir.
Sir,
Yeah, বলো.
why do you use the left-hand rule in this case?
Because our aim is to find the force using the current. The incoming direction of the charge particle is given. Magnetic field is also given. So these two are our inputs. The unknown is in which direction is gonna bend. That's why you use the left-hand rule. Left-hand
Thank
rule,
you.
বুঝছো?
হ্যাঁ স্যার বুঝছি।
Left-hand rule is used to find the force direction, whereas right-hand rule for the case of generator is to find out the direction of the current, in which case the magnetic field and the force are given and current is the unknown. So that is not the case over here. Current in this case is given because the direction of the charge particle incoming is already provided. আচ্ছা এটা গেল, এখানে লেবেল করতে বলছে। So labeling না করলে তোমাকে এই 2 মার্ক দিবে না। Only drawing the figure is not gonna score you that mark. You have to do labeling.
Sir.
Yes.
So when we're sketching, can you show the difference between drawing a parabolic and a circular path?
Manual drawing can prove it to be pretty difficult to distinguish them. The a parabolic path would have decreasing gradient or increasing gradient behavior, and a circular path is circular. Or if I mean, I can show you how what is the shape of difference in between them. And let maybe
একটা কোয়েশ্চেন ছিল
বলো কত নম্বর কি কোশ্চেন?
beta particles bend more in a magnetic field than alpha particles, right? Because they have less mass.
Yeah, that's true. আমি এখানে um, okay, this might as well actually be a good graph to show you. This red thing is a full circle. It was drawn in Desmos, yeah, exactly. Whereas this blue and the green shapes, these are the parabolas. So that's the difference, sort of. A circle is defined that in a way that it has equal distance in its trajectory from a specific point. Whereas the parabola is defined as it has a fixed ratio of two distances, which is called the eccentricity of the parabola. So if I take this figure, have a look. This is the definitive direction. This is a very good figure to define a parabola. So I just needed this picture. Open image. What you can see over here, this is what we call the focus of the parabola. The parabola is made in such a way that it will always have a fixed ratio. Is it have a fixed or is it equal? It's supposed to minus a 0. I
স্যার
think
প্যারাবোলা কি জিনিস আবার বলবেন, আমার ইন্টারনেট খুব বাজে।
parabola is a specific geometric shape where it has an eccentricity of 1. Eccentricity of 1 means that you have it has an eccentricity of 1.
Is one
Eccentricity. Eccentricity is defined as the ratio for which defines the parabola. For example, you have a definitive vertical line and you have a specific point. A parabola is defined as the trajectory of points in which the distance of all of those points is such that the distance of this point from the vertical line and the distance to this very specific point, which is called a focus, they are all equal. মানে হচ্ছে মনে করো আমাদের এই প্যারাবোলাটা এখানে নাই। If you are trying to draw a parabola, we are going to plot points on this segment such that all of those points will have equal vertical distance from this green line, which is called the directrix, and with this position of point, which is labeled as focus. So here, these two lengths are exactly equal to each other. This diagonal length and this length are supposed to be equal to each other. This length and this length are supposed to be each other. So that's the property of the parabola. In this case, it's not appear to be very equal, but usually they are supposed to be equal. বুঝছো?
Yes, sir.
It's a
It's
mathematical
for all
relationship.
the
So it doesn't have
parabolas,
a
right?
physical definition, so I cannot essentially do a physical definition for it. Actually, I don't know.
স্যার প্যারাবোলা কি আমাদের সিলেবাসে আছে, মানে লাগবে আমাদের?
No. You just have to know that charge particles in an electric field behave in a go in a parabolic shape. Charge particles in a magnetic field move in circular shape. এইটুকু শুধু আছে তোমাদের। প্যারাবোলার ফুল ডিটেইলস কিভাবে হয় না হয় এত কিছু নাই।
স্যার
বলো।
স্যার বেটা পার্টিকেলস হলো আমরা কম্পাস দেখবো, আলফা তো আরো কম ডিফ্লেকশন হবে, ওটা কিভাবে আনবো?
আচ্ছা, এটার কারণটা খুব সিম্পল। সেটা হচ্ছে যে আচ্ছা, I'm trying to discuss over here. Everyone, please pay close attention that in the same electric field or in the same magnetic field, beta particles have a stronger deflection or they have a smaller radius of arc compared to alpha particles. Why is that? The amount
this is because
of
beta particles are
acceleration
lighter.
the amount of acceleration that you're going to get is dependent upon two factors. Acceleration comes from force because acceleration is forced by mass. So force is also a factor and mass is also a factor. If you compare the charge amount between beta particles and alpha particle has a charge magnitude of +2 or 2 magnitude যদি বলি 2, whereas beta particles have a charge of 1. So in terms of charge, alpha particles have double the charge. But in terms of mass, each alpha particle is nearly 8,000 times heavier or more massive compared to a beta particle. About, I'm giving an approximation. So this makes the acceleration on a single beta particle far too stronger compared to the acceleration of an alpha particle within the same field. That's why alpha particles bend less, which means their acceleration is less. In terms of magnitude, they experience double the force. Let me elaborate what I mean. Let's say An alpha particle in a magnetic field experiences 20 Newton force, whereas a beta particle experiences a force of 10 Newton force. That is the amount of force variation. But for an alpha particle, let's say that 20 Newton force is used to move a mass of 100. Whereas for the case of a beta particle, that 10 Newton force is used to move a mass of 0.01. So beta particle has half the force compared to an alpha particle because it has half the charge compared to an alpha particle, but its mass is way too much smaller compared to the alpha particle. That's why the acceleration is much too stronger, which makes the curvature really steep. বুঝা গেছে কিনা?
স্যার একটু আরেকবার রিপিট করবেন, মানে অ্যালফা পার্টিকেলের একটা।
The alpha particle experiences double the force compared to beta particle because of the charge difference. Alpha particle has a charge of +2, beta particle has a charge of -1. So it is a charge that defines how much force do you have. But acceleration comes from the ratio of force by mass. So acceleration is acted upon by the force and also the mass. So in terms of force, alpha particle always experiences double the force of a beta particle. But the mass of a beta particle is about 8,000 times smaller compared to an alpha particle. So the acceleration value of alpha particle is far too smaller compared to the acceleration value of the beta particle. For example, let's say for the alpha particle, you have 20 Newton force moving a mass of about, let's say, 100 units. Whereas for a beta particle, you have 10 Newton force moving the mass of about, let's say, 0.01 units. So you have very small mass. That's what makes the acceleration really, really large, which means it can turn really sharply, having a smaller radius of arc in any field. I can show you one of the figures over here. I mean, it's pretty simple. Other than going up and looking in your book, এই ফ্যানটা চালা দাও তো। This is what I'm talking about. The alpha particles have bent quite less, whereas the beta particles bend really sharply. Like they have severely high acceleration compared to the alpha particles. বুঝা গেছে?
Yes, sir.
আচ্ছা স্যার, এটা কি মানে একদম করে রিটার্ন করে ফেলে বেটা পার্টিকেল?
হ্যাঁ, বুঝি নাই।
মানে is it that sharp যে মানে it returns back to its original path? I
Well,
mean,
that is dependent on how far of this path are you observing. If, for example, that depends on how far of this path are we observing. What I mean is that if we observe this entire path, it appears that the beta particle is actually coming back to the same direction. But if we observe a much smaller section, let's say if we observe only this much section, then only this much section, let's say, then we could say that the beta particle is not necessarily coming back to its original direction. It depends on how far that do you allow it to bend. বলো, বুঝি নাই।
so স্যার আছেন?
হ্যাঁ, আমি তো আছি, তোমাদের কথা বলো, শুনতেছি।
আচ্ছা স্যার, so can we say that in the large picture the beta particle can come exactly the same point it started its journey? I mean, both beta and alpha.
Given enough space, yes. But that would require an extremely strong magnetic field applied over a really large amount of space. If you want to have even the alpha particle come back to the source position, like a really strong magnetic field over a really large area. Pretty difficult to achieve practically, if you ask me.
স্যার বেটা পার্টিকেলের প্যাথটাকে আমরা পারফেক্টলি সার্কুলার শো করব, মানে একদম সার্কুলার ওরকম।
এখানে দুটা প্যাথই alpha particle, beta particle, দুটা প্যাথই সার্কুলার। This one is a circle of a much smaller radius. This one is a circle of a really big radius. But
If
they're
this is
both circles. বলো।
Sir, if this is taking in a closed system, then if the beta particle gets circularly diverted and collides with one of the walls, won't it get reflected?
Reflected by?
The wall. It will exert a force on the wall will exert a force on the beta particle.
Yeah, definitely. That's exactly how we detect the position of the alpha particles and the beta particles. The wall of this chamber is not essentially a blank wall. We have detector fluorescent material coating all around so that we can locate exactly where the beam of the beta particles or the beam of the alpha particles are bending at. Otherwise, how would we detect where they are going? They are not naturally visible. The way we can find out where they are by locating the position where they are hitting on the fluorescent coating inside the room or inside the chamber, if you ask me.
Sir.
Sure. আচ্ছা, তারপর কোশ্চেন দেখি আমরা। এই কোশ্চেনটা সলভ করো ব্রাবান। This is an interesting question. Figure 8.1 shows a half-scale diagram of a relative source stored in a safe way. We have a hinge, we have a lead inner container, we have wooden outer box with hinged lid, and we have the source. The question is asking, try to think about it. How do you answer this?
Sir, what is the hinge made up of?
It could be made up of anything, plastic, wood, metal.
Oh, I mean, sir, this white part, sir, this is also, the entire thing is wood.
The entire thing is lead.
No, no, that's not what I'm talking about, sir. I mean, sir, this part. এই part, এটা কি wood?
Yes, as per the question, yes.
Okay, sir. Undo. Okay, okay.
Sir, 17 এর answer বলি।
Yes.
Sir, the alpha and beta particles are effectively absorbed by the lead inner container, but since the gamma rays have a really high penetration power and the lead layer is not thick enough, some of the gamma rays can escape.
Beautiful. This is a good response. বলুন বুঝছো কিনা দেখো।
But sir, isn't lead thick enough for gamma rays?
Gamma rays are virtually impossible to absorb 100% by any amount of substance of any thickness. By having a thick enough lead container or lead barrier, you can reduce it to a value that our body can handle or our body's immune system can manage. But because gamma rays are so small, given any amount of thickness of material, lead or other, doesn't matter, we can never guarantee that 100% of the gamma rays would be stopped. Some gamma rays would always penetrate through any amount of substance that you or barrier that you design. So,
স্যার
হ্যাঁ বলো।
But
স্যার
but
তাহলে স্যার একটা নিউক্লিয়ার রিঅ্যাকশন যে স্যার যে ভেসেলের মধ্যে হয় স্যার ওটা থেকেও তাহলে গামা রেজ এক্সেপ্ট করে স্যার। তাহলে যারা ওখানে কাজ করে স্যার ওরা তো সবসময় এক্সপোজ হচ্ছে ওই রেডিয়েশনের সাথে।
Exactly. So that's why usually they are given. They usually don't work there for a really long amount of time. And one of the things that you need to consider that gamma rays have very high penetrability, which means even if a person is pretty close to a gamma source, most of the gamma rays would also still penetrate through them and eventually go through the outer side. A very small fraction would be absorbed in the human body. these people who have to actually work inside a reactor, if they ever have to, then they are usually they usually have to undergo a lot of protection, and after they are done with their job, they have to take radiation shower, they have to take certain medications, and they have to be away from radioactive sites for a given duration of time so that their body can uh, deal with the amount of damage that they have come across within that period. All of these things have to be maintained properly. বুঝছো কি বলছে?
আচ্ছা স্যার,
জি স্যার।
ইজেন্ট স্যার এই যে রেডিয়েটিভ যে রিঅ্যাকশন হয় স্যার, এগুলোতে আলাদা কন্টেইনারে হয় না স্যার? আই মিন অ্যাজ শোন বাই দ্য অ্যানিমেশন ইউ ওয়ান্স শোড।
Are you talking about reactor or bomb?
রিঅ্যাক্টর।
Yes, definitely. আলাদা container হয়. Yes.
So they do not, people don't go inside that reactor. I mean, so why
No,
would
no.
they
I,
keep
I was referring to the situation when, let's say, you have to do an overhauling or repairing of the reactor.
Yes sir.
In those cases, you uh, typically it is preferred to send robots these days because robotics have developed that much. But when nuclear energy was initially introduced to us, robotic energy was not that much developed. So there was a certain duration of time, a decade even, where actual physical human beings in some cases had to go in, get into a reactor if there is some difficult repairing or overhauling to attend to.
Achha,
Or
sir, you once said that gamma rays are energy, which means that when they ionize, they basically, I mean, transfer all their energy to the outer shell electrons. So how do they exactly penetrate so fast? Hello?
think about the solar system and think about a comet. Comet. If a comet enters the solar system, get affected by all the gravitational field and such, but still, in terms of probability, how probable is it for that comet to hit any of the planet or even the sun if it's only a very small comet?
Oh, which means they are energy, meaning they're still even smaller than electrons.
They are extremely small. Yeah, definitely. They are smaller than beta particle. Beta particle is the electron. So yeah, they are so small that they basically travel to the empty space of the atom and goes through.
But should they collide with something, all of its energy transfers to that little thing it collided with?
Yes, if they collide with something, they transfer all of their energy pretty much at the same time.
তাহলে স্যার এই কোলাইডের জিনিসটার এনার্জি শেষ হতে তো অনেকগুলা অন্যান্য জিনিসপত্র কোলাইড করতে হতো, পার্টিকলস দের, রাইট?
When one of the gamma photon or gamma ray gets absorbed, it is possible that that can lead to subsequent breakdown of other particles. I'm talking about physical damage, not essentially ionization. That is possible, like a small cascading event. But the probability for gamma rays themselves to get absorbed within a regular density material is quite low.
Yes, sir.
So B number, how discover and explain how the teacher should remove the source from the box safely. How do I approach this?
Teacher must remove the substance with the lead cover.
He should wear lead linen gloves and clothes.
Wear
The teacher
protection.
should wear protective clothing.
And
Tweezers.
Use other equipment to like grab hold of the box, lead box.
there is a name for the equipment. You need to mention that equipment.
Pulley.
No.
Pliers na. Pliers.
সাপ ধরে এটা দিয়ে।
Pliers is can
Tongs.
Yeah, I was looking for that word. Tongs.
Tongs.
Do you guys know what a tong is?
No, sir.
No sir.
It's the device by which মিষ্টির দোকানে মিষ্টি তোলা হয়. Small armed tweezers.
টুইজার্স হবে না?
Oh yeah, these are called tongs. Tweezers
Oh,
are usually very
মাংস তুলে
হ্যাঁ
হ্যাঁ
স্যার
কি
রানের মাংস তুলে দেন এটা দিয়ে।
এই তো হ্যাঁ মানে
মাংস তোলা যায় বাট
extension
কি
of
তুলে?
your hand where you don't
আরে
want to touch the stuff by your own hand. Nine just doing wrong, third, doing wrong.
স্যার আপনি কিনবেন এখন?
No,
স্যার আমাদের
Tongs are an
আরেকবার
all-purpose
বলবেন কি?
utensil that can be used for anything from pulling something out of boiling water to pulling something off a hot sheet pan. And those are tongs.
this is tutorial for
Should
how
we
to use
use
the
that?
tongs. Oh man. Okay, why not? তারপর the source is brought near a radiation generator. Name a suitable generator. What is the name of
Diagonal tube.
the diameter?
GM tube.
GM tube. Yes.
স্যার
Just
আর
how would
এটা
you
কিভাবে অ্যানসার করব আরেকবার বলবেন?
random? এটা কিভাবে আনসার করবা?
স্যার ফার্স্টে উইদাউট সোর্স মেজার করব।
ও না স্যার র্যান্ডম মিনিংটা জানি কি স্যার এখানে?
Guess.
স্যার পার মিনিট কয়টা হবে এটা তো জানবো না, যেহেতু র্যান্ডম। সো
আব্দুল্লাহ
Right.
আপা বলো। বুঝি নাই।
যেহেতু র্যান্ডম, সো মানে প্রত্যেক মিনিটে যে কয়টা করে হবে ওটা তো আমরা বুঝতে পারবো, মানে কয়টা দিকে হবে ওটা তো বুঝতে পারবো না। সো রেটটা সেম হবে না, the rate will vary.
Yeah. What you're proposing is correct, but how do you write this for the answer?
Sir, we will use
The intervals between
stopwatch.
the emissions are not same,
And then
and thus the rate is not same.
Sir, এটা হতে পারে না স্যার যে we will use a stopwatch and count the number of emissions per minute.
We measure for different directions.
all of you have mentioned something about recording the measurement with equal interval. But then what property of those count should tell us that it is random? এটা কেউ বলো।
Sir,
Oh,
for
sir,
each minute
that
the
is-
counts will be different.
Exactly. That's exactly what I was looking for. That those counts, number of counts in the GM tube for equal time interval should be unequal or they should be different, proving that the radioactivity is a random process. So we word important. You have to use that word that those counts made for equal time intervals are not going to be equal to each other or they're going to be different, proving that radioactivity is a random process. Buchi will say.
Yes, sir.
It's a 2-mark thing. So measuring the count for equal time intervals scores you the first mark. Mentioning each of those counts would be different from each other scores you the second mark.
স্যার সাবির বলেছে বি এর আনসারটা আরেকবার বলতে।
Discuss explain how the teacher should you remove the source from the box safely. The teacher should wear lead lined dress and use tongs to take the source out of the box.
Sir,
Yes, sir, understand.
lead lined dress. I mean, okay, sir.
Yes. Complete the table of Java creation vertical charge position. How you question? How you question? Acha. এটা একটু try করো number C. A different isotope used in hospitals has a half-life of 13 hours. A sample of this isotope and a detector are placed in a lead box. The count rate is recorded every minute for 3 minutes. The values obtained are this, and this per minute. Question why the 3 readings are not the same. It answer কি হবে?
Background radiation.
Random, sir.
একটা ওয়ার্ড না, একটু সেন্টেন্স বলো।
Radioactivity is random.
Radioactivity is a random process. Beautiful. Estimate the time taken for the average count rate to fall to 200 counts per minute. So প্রথম কাজ যেটা করতে হবে, আগে অ্যাভারেজ করতে হবে। ওই তিনটা ফেলে অ্যাভারেজ করে দেখো কত আসে। এভরিওয়ান, ওই তিনটা ফেলে অ্যাভারেজ করে দেখো কত আসে।
স্যার 3200।
সো 3200 কে অ্যারো ফিগার দিয়ে বের করো যে 3200 কে কয়বার হাফ করলে 200 হয়। এভরিওয়ান ডু ইট।
Sir, 16.
তারপর
6 times. How many times do you have?
4 times.
4
তারপর
times,
স্যার
sir.
4 times.
মানে অ্যারো ফিগারে তোমার অ্যারো কয়টা আসছে? 4টা।
জি স্যার।
Yes, sir.
So you would require 4 half lives. So what will be the total amount of time?
4 into 13.
4 into 13 hours. So ওইটাও দেখাইতে হবে। So এখানে 3 মার্ক দেওয়া আছে। I believe the first mark is for doing the average, the second mark is for the arrow figure, and then the third mark is to multiply the number of half lives with the 13 to give you the final correct answer. I'll still have a look at the mark scheme to find out how did they distribute this 3 mark. This is question number 18. Let's have a look at that one. The mark scheme by করে নেই। কত নম্বর কোশ্চেন দেখলাম যেন এটা? 18 এর সি। Both you should seen as average exactly. Attempt to have half to 4 half lives and then the perfect answer. Yeah, exactly what I said. Beautiful. We'll have a look at the examiners report as well. Just because we are here, number C says, a very disappointingly small number of candidates explain the variation in the count rate was due to the random nature of the distribution. Many other explanations were offered. This difficult calculation was rarely answered completely correctly, but many candidates made some important points and scored some mark as a result. What? This was a difficult calculation? Hold on, এটা তোমাদের কাছে difficult লাগছে?
না স্যার,
No, sir.
আমরা স্মার্ট।
That's weird. আচ্ছা, যাই হোক। The sample and the reactor are taken out of the lead box. The count rate rises slightly because of the background radiation. State one cause of background radiation.
Cosmic radiation.
Background radiation এর reason কি হতে পারে?
Cosmic rays.
Cosmic radiation.
Cosmic radiation আর কি?
That from the earth, from the rocks in the earth, মানে underground.
Exactly, or to be more specific, you can say that from radioactive ores underneath the Earth's surface. That would be very specific. Radioactive ore. Do you know what ores are?
Yes, sir.
Ore মানে হচ্ছে
Raw
Substances in
material.
which the metal is contained.
exactly raw material from which metal is extracted. Beautiful, thank you. And then
Sir.
we can also have increased background radiation due to nuclear testing. And I think that's pretty much it. The
Sir,
massive
nuclear testing মানে কি nuclear bomb testing?
nuclear bomb testing, yeah, mostly.
Or
Even
sir,
we've
can
done
we
a lot of nuclear bomb testing since the development of this technology, which actually significantly increase the background count of the entire world, Earth altogether, compared to what it was before the 1940s.
sir, can we say that if there is an sir, we can say that, sorry.
We can always say if there is a will, there is a way.
Nah, sir, I was going to ask that if there is a high rate of background radiation, can we say that there are radioactive sources, radioactive ores underneath the ground? But then I thought that that's not
Well,
correct.
that can be one of the reasons, but we cannot essentially say that is the
Yes,
only
sir.
reason. That can be considered to be one of the reasons, but we cannot say that is the only reason. That would be
Yes, sir. then
not very accurate.
size dropped.
Out of many reasons, that can be very much one. Yeah, that's true. So we go for the next one. We have over here. Acha.
Sir, what happened?
One of the piece of paper from my table fall off. The ব্যাপার না পরে উঠাবো। আচ্ছা এখানে আমাদেরকে একটা গ্রাফ আঁকতে বলছে। হাফ লাইফ 15 আওয়ার্স, সো এই 15 আওয়ার পরে অর্ধেক হবে, আরেক 30 আওয়ার পরে আরেকবার অর্ধেক হবে। এখানে স্মুথ একটা কার্ভ আঁকবা। এগুলা সহজ জিনিসপত্র। এই যে this is one of the question. Determine the counter due to the isotope 30 hours before the start of the experiment. Whenever they say before, which means you now have to multiply by 2. You have to double the count by the number of half lives involved within the time frame. এখন এখানে আমাদেরকে বলছিল half life হচ্ছে 15 hours তো গেল।
Sir, এর মানে কি from a point before this time there was still going on radiation, and after this time we are drawing this graph and we are now asking to see what was going on 30 hours before.
Exactly.
Okay.
Because radioactivity is a continuous process. There is no way we can speed up or slow down this process. So before we started our observation, radioactivity was still there. This question is asking us to calculate out the count rate of the specimen 30 hours before compared to what we are considering right now. So for before every 15 hours, the counter would have been doubled. So in this case, you have to double it twice. That's pretty much it. So the reason I'm highlighting this question is that you have to read very carefully. Is the question is asking after or before? Because for before, you have to double the rate. If it is after, you have to halve the rate. It goes on like that in a fraction of in a multiple of 2.
Sir?
Yes.
Sir, এই যে স্যার এই যে গাইগার মুলার টিউবের মধ্যে একটা কি ইলেকট্রন অ্যাভালান্স কি জানি হয় না, ওটা বোঝাতে পারবেন? লাইক ক্যান কারেন্ট ফ্লো হয়?
আবার বলো।
স্যার গাইগার মুলার টিউবের মধ্যে ক্যান কারেন্ট ফ্লো হয়, এটা বোঝাতে পারবেন? সামথিং অ্যাবাউট ইলেকট্রন অ্যাভালান্স কি জানি গুগলে পড়ছি।
স্যার এটা আয়নস এর জন্য হয় না স্যার, ইলেকট্রনস কেন হবে? There are inner gases, I thought, inside Geiger-Müller tubes, which cause this count rates. Right, sir?
Incoming ionizing radiation produces ionization in the argon gas. All of the ionization that is produced over the duration of the charged particle passing through the argon gas, they all produce electrons within a very short period of time. Because of the high electric field concentration, where the central rod is being positively charged anode and the outer circle is negatively charged cathode, all of those free electrons are attracted very strongly towards the anode. Whenever these electrons touch the anode, they produce one pulse of current, like beep, in that manner. One pulse of current, not a continuous current, because all of these electrons produce one pulse of current. So one pulse of current is considered as one breakdown that was detected by the GM tube that happened outside the GM tube. So if we are aiming the GM tube towards the radioactive isotope, and one ionizing radiation comes from the radioactive isotope into the GM tube, it produces a series of ionization within a short time, which was defined as the avalanche. And as a result, there are quite a good number of electrons produced within a very short time. All of those electrons reach to the anode pretty much at the same time, because they are produced within a very short distance as well. And they produce one spike of current within the counter. That is that is what we define as কি বলতেছিলাম ভুলে গেছি। Acha, that detection of a pulse of a current is considered as one breakdown outside the GM tube. বুঝা গেছে?
আচ্ছা স্যার, one pulse of current স্যার এটা এক্স্যাক্টলি হয় কিভাবে স্যার?
By the absorption of the free electrons produced by the ionization from the ionizing radiation.
I mean, it is a random process, na sir. So, why would be one pulse. I mean, it would be continuous, right, sir? As far as we know.
No, there will be gaps.
So one count is one ionization.
One pulse of current is considered as one ionizing radiation entering the gym tube, which is considered to have come from one breakdown in your specimen.
Yes, sir.
আচ্ছা তারপর আচ্ছা তোমাদেরকে একটা কোশ্চেন করি I'm not sure if this question is in the worksheet or this was in the class test paper. Why is it important to have a radioactive specimen inside a locked box?
স্যার
Because radioactivity কমে আসবে একটা টাইম পর, না
হ্যাঁ
হলে
because the
না হলে
air
একটা টাইম
particles
পর রেডিওঅ্যাক্টিভিটি কমে আসবে, একদম জিরোর কাছাকাছি চলে আসবে।
স্যার কোশ্চেনটা একটু রিপিট করবেন স্যার?
the air particles inside the
Why is it important to keep a radioactive specimen inside a locked box?
The air
Safety?
temperature is radioactive.
You also?
Because
air-
there's always a possibility that that the radioactive particles can escape.
No, that's not the
The air might get radioactive.
Abdullah বুঝি নাই বলো
So the air might get radioactive.
No.
যাতে র্যান্ডম মানুষ এসে না খুলে।
That is correct.
আমি বাচ্চাদের কথা বলতেছি।
To prevent outbreak of disease, genetic diseases because of iron.
Kids, try to understand. The key idea of this question was locked. I did not say shielded at all. Did I say shielded lockbox? I said inside a lockbox. This lockbox, as far as I'm concerned, this lockbox could be made out of thin plastic.
তাহলে স্যার ইয়াসিরের কথা একটু ঠিক স্যার।
In my question, anywhere it was shielded with lead or anything else. I only mentioned it's inside a lockbox. The only reason you should always keep your radioactive specimen, if you have any, inside a locked box to avoid unauthorized access. That's it.
তাহলে স্যার ইয়াসিরের আনসারটাও তো হবে বাচ্চারা যে কোনো সময় খুলে ফেলতে দেয়।
So you could say for a specific group of people, but unauthorized access is the general term for it. To avoid unauthorized access. You don't want this thing to be in the hands of the wrong people. You don't want this thing to go into the hand of uneducated people. You don't want it to go to the infants. You don't want it to be misplaced, period. You don't want to lose a radioactive specimen. So that's the purpose why it should be in a locked box. এটা তোমাদের স্কুলের পরীক্ষা আসতে পারে টিচার এটা অনেক লাইক করে এই কোশ্চেনটা because unless as far as my experience goes, almost no one, unless they previously known that this was for to avoid unauthorized box, by hearing the term lock, they assume that the box is already shielded. I mentioned lock. Did not mention lock. So there is nothing to preventing the radiation to go out. You are assuming it. Do you get my point?
Yes,
আচ্ছা স্যার এটাও কি হতে পারে না টু অ্যাভয়েড অ্যাক্সিডেন্টাল dropping or falling?
The box was locked.
Yes, now it
The box was not locked with a frame. That was not a part of the question.
স্যার বুঝিনি স্যার।
The box itself was locked. The box was not locked with a frame or with a stand or inside an almirah. I didn't mention that. I only mentioned the box was locked. All right, we'll move on. এখানে কি নাম্বার বি এটা আনসার করো It's a 5-mark question, so pretty big, pretty big marks. Think.
B1.
B এর দুইটাই 2 precautions 2 mark, তারপরটা 3 mark. So what did you write?
বলি
Using a tongue
The lead line
and storing in a lead container.
স্যার শুধু লেডি কি ইউজ করা যায় আর কোনো হেভি মেটাল ইউজ করা যায় না?
Well, lead is the cheapest yet dense enough to stop gamma radiations to a very high portion. So it's a matter of availability, which means price, and functionality at the same time. So lead is sort of like at the sweet spot of being cheap enough and also working well enough for us.
That's why lead is more popular, understood.
Sure. So one is that it would be that whenever they're handling, they must be using protective clothing and use tongs, and never and also while storing, they must definitely store it within a lead lined box. And you can also mention locked box that it can be used for extracate it, should be used for extracate it. And then number 2 says the effect of radiation on the human body depend on the properties of the radiation. Question: why a source emitting alpha particles inside the body is more dangerous than a source of the same activity emitting gamma rays inside the body?
So alpha particles are
Alpha
more
particles cannot penetrate the skin, but once inside, they can ionize and cause deformation of tumors and cancer.
Very fast.
Yeah.
And yeah, everything that you said is correct. Would you like to add? Would anyone or you like to add anything else?
Gamma rays are less ionizing and they can easily penetrate to the body. So
alpha rays can't get out of the body easily. They stay there.
They stay there and deal damage by
Gamma rays have high penetration power, so they can easily leave the body. So
without dealing much damage.
They are not stored inside the body and cause further damage to the body.
How can they do further damage? I mean, they are ionized.
I mean, not further damage.
Achha.
That's what I said.
I was looking for one specific point, which is that everything that you said is absolutely correct. None of you are wrong. Everything that you said, all of you, each of you said is absolutely important and correct. Another point that I was looking for is that alpha particles have the least penetrating power. So all the ionization they make is concentrated in a very small space, giving a higher probability of tumor and cancer growth. Whereas gamma radiations can penetrate through human body very easily, and because they have less ionizing power, so they ionize a small number of particles over a large distance. So the concentration is pretty low. So the probability for tumor growth or cancer growth is also significantly lower. I'm talking about the concentration of the ionized location. That's what I'm trying to highlight here. Additional to what you said, what every one of you have said is also very important. I'm adding one more point to it about the concentration of the region in which the ionization occurs. এই পার্টটা কি বুঝতেছো সবাই?
জি স্যার। স্যার এটা কি 5 মার্কস এর জন্য মানে 2 প্রিকশনস তো 2 মার্কস 3 মার্কস এর জন্য কি এটা বলা লাগবে স্যার?
We're gonna see right now. This is
okay, sir.
Number 20. Let's have a look what the examiners want out of
Sir.
it. Yes.
স্যার আমার 9টা বাজে একটা ক্লাস আছে, আমি যেতে পারি?
আচ্ছা ঠিক আছে।
স্যার আমারও 9টায় ক্লাস আছে আমি গেলাম।
আচ্ছা ঠিক আছে।
এক্সামে তো আমাদের ওয়াই অ্যাক্সিস এর স্কেলিং করতে বলবে না গ্রাফগুলোতে, রাইট?
Question number 20 marks scheme 9. We only have the examination paper, but that should be good enough. This was question number B3. So এই পার্টটা পড়ো, বিয়ে পুরো মার্কস পড়ো। The answers to this section were straightforward with the use of tongs or a lead absorber to keep the source at a distance from the experimenter or to absorb any radiation emitted. However, a candidate who merely refers to protective clothing must give more detail as to how the clothing protects the experimenter. Okay, so lead-এর কথাটা আসতে হবে, tong-এর কথাটা আসতে হবে. These are the two important required words. Then it says only a few candidates scored 1 or 2 marks from the 3 available for this section. It was sometimes recognized that the alpha particles cause more ionization than the gamma particles, but it was rare to find a statement that the particles cause cell death, cancer, or any specific harm to the body. Okay, many of the students did not write about the end output of the whole radiation problem. In suggesting why alpha particles are more dangerous when emitted inside the body, explanations that gamma particles were able to leave the body were usually successful, whereas it was rarely stated that alpha particles were absorbed within the body, and often there was a wrong statement or implication that alpha particles cannot escape, thus keep moving around the body to cause damage. No. So thus keep moving around the body to cause damage is the wrong thing. It comes out, does the ionization, get absorbed. It is not like it's not like a germ or a microorganism that is trapped inside the body. No. The beta candidates recognize that the particles were absorbed within the body and thus were unable to leave. Okay, so yeah, I think it makes sense. It makes good sense. দেখো কার কোন কোশ্চেন আছে কিনা দেখো।
আর more details to the protective clothing টা কি বলবো?
কোনটা?
Which is in reference to protective clothing must give more detail as to how the clothing protects its ওটা মানে আর
ওটা মানে হচ্ছে if someone only writes that the experimenter should wear protective clothing and use tongs, তাহলে তাকে শুধু এক মার্ক দিবে টং এর জন্য। protective clothing টা কিভাবে protective করতে হবে, I mean there should be lead lining or there should be lead shielding in the clothing, এই কথাটুকু মেনশন থাকতে হবে। only mentioning the term protective clothing itself is not good enough. how that protective thing was made protective এটা মেনশন থাকতে হবে, বুঝছো?
Yes sir.
Basically radiation গুলো কয়েকটা পার্টিকেলদের আয়নাইজ করে once they're out of energy then they're absorbed, right?
Exactly.
আর এই absorbed হওয়ার পর কি করে? Destabilizes the cells into which it was absorbed, right?
The alpha particles convert into helium nucleus. The beta particles simply make something -1 charged. Gamma radiation simply get lost because they are energy, they are absorbed, and once they are absorbed, they are no more.
Yes, sir. So helium atoms inside the body are definitely not healthy, right?
No, helium atoms inside the body is not a big deal because helium is a perfectly neutral gas. It can come out of your body through any mechanism that the body can handle it. But before it becomes helium, it does the most amount of damage.
By ionizing and killing cells, causing cancer, etc.
Exactly. তারপর দেখি
স্যার।
Yes.
স্যার আমার 9টা একটা ক্লাস আছে, আমি যেতে পারি?
আচ্ছা ঠিক আছে।
বাই স্যার।
এগুলো তো সব সহজ কোশ্চেন দেখা যাচ্ছে।
স্যার মাঝে মাঝে তো সহজ জিনিসটাই কঠিন হয়ে যায়।
It's true, it's true. It's life. এটা ট্রাই করো। 5 mark question. এটা তোমাদেরকে অনেক ডিটেইলসে পড়াইছি। Think about it, what kind of block diagram you're gonna give. Think about the description you're gonna write so that your answer would be sufficient for a 5 mark answer.
স্যার ব্লক ডায়াগ্রাম মানে
ওই যে রেক্ট্যাঙ্গলের মাঝখানে একটা লেখা, অ্যারো দিয়ে আরেকটা, ওটা ব্লক।
স্যার স্যার ব্লক ডায়াগ্রামটা তো বেসিক্যালি হচ্ছে এনার্জি কনভার্সন না স্যার?
পাওয়ার প্ল্যান্টটার বিভিন্ন পার্ট কি লেবেল মানে বলতে হবে ডায়াগ্রামটাতে?
Not essentially. I mean, the more detail you make your block diagram, the less you can write in your description, and vice versa. So they should complement each other. What you show in your block diagram doesn't have to be repeated in your description.
তাহলে ব্লক ডায়াগ্রাম এভাবে করতে পারি যে ইউরেনিয়াম atoms split energy transferred to D2O, D2O transfers energy to H2, H2O converts into steam, rotates turbine, electrical energy generated and used. Not enough, right?
I think
আচ্ছা স্যার স্প্লিটিংটা আমরা মানে কোথা থেকে মানে শুরু করব স্যার? মানে পুরা স্টার্ট থেকে ইউরেনিয়াম রডের ওখানে যে ওয়াটার পাস করা হয় ঠিক ওখান থেকে?
এটা কি তোমাকে দিছিলাম না?
ইয়েস স্যার।
স্যার আজকে বসে বসে প্রিন্ট করলাম পুরো জিনিসটা।
Good stuff.
স্যার স্যার এটা আবার
এই যে
পোজ
ব্লক
দিতে
ডায়াগ্রাম,
পারবেন স্যার?
এই যে ব্লক ডায়াগ্রাম। Nuclear energy in the nuclear fuel fission, heat energy to primary coolant, heat exchanger, heat energy in steam, kinetic energy of turbine, electrical energy in generator.
স্যার এটা কি নোটসে দিও না?
হ্যাঁ
লাইক আপনি যেটা প্রিন্ট করবেন নাকি ওটা
হ্যাঁ
আরেকটা?
হ্যাঁ, এটা থাকবে। জাইনের হাতের লেখা অনেক ভালো। One of the biggest challenge of operating a nuclear power plant is the nuclear waste management. These wastes are not biodegradable. They are radioactive waste with elements of pretty long half-lives. This means these waste materials will keep on giving up energy for a very long time. Since radioactivity is a spontaneous process, we cannot do anything that will stop the radiation, which would have been very nice, or speed up the process so that they emit all the ionizing radiations over a short period of time and are no longer radioactive. So we just have to keep them in a place where they cannot affect the living organisms too much. Usually the radioactive waste are preserved in big underground reservoirs where the water waste are kept in closed sealed containers and are kept underwater. It's done because water can absorb the ionizing radiation pretty effectively, and these breakdowns produce significant heat which can be controlled by the water. For figure of the reactor, refer to textbooks and Google. Actually, আমি পোলামান থেকে ডিকটেশন দিয়ে যেগুলো লেখাইতাম, হায় হায়, I was such a good teacher back then.
Sir, you're still the same. Sir, what's the difference?
No, I'm not the same.
Sir, it will take you just 2 seconds to make us start writing the notes again. আপনি বলবেন আমরা লেখা শুরু করে দিব।
কথা বলা বন্ধ করা তো তাহলে হবে।
এসব
স্যার এটা কি আমরা একদম ইলেকট্রোম্যাগনেটিজম থেকে রেডিওঅ্যাক্টিভিটি পর্যন্ত করব? আপনি বলবেন, আমরা দেখবো একসাথে।
ওর সর্বনাশ। আমি তো এটা করতে গেলে বুড়া হয়ে যাবো। I what can I say? I exclusively avoided this process not to go through the process, and hence where the printed notes and everything comes by. I hate doing dictations, but there was a time when I used to do that, so I shouldn't say that I despise it altogether. All right, so there are 5 marks in it. Clearly, Babalo. In the reactor, uranium undergoes fission to give up nuclear energy into heat energy in a chain reaction, which is controlled by control rods. The heat energy is transferred by primary coolant into a heat exchanger, which boils up normal water. The steam is thrown into a turbine, where the heat energy of the steam converts into kinetic energy of the turbine. This kinetic energy rotates a generator, which converts the kinetic energy into electrical energy. I might write this much, and also the regarding relevant block diagram shows up. এটা কত নম্বর কোশ্চেন? 22.
স্যার আমরা ডিউটেরিয়াম কেন ইউজ করি একটু আবার বলে দিবেন স্যার?
না, দেখাচ্ছি।
সরি ফ্লোচার্টটা লাগবে?
It's not essential, but you can read. It's pretty simple. আমি মুখে যা বললাম সেই জিনিসটা এখানে অ্যারো দিয়ে লেখা আছে।
স্যার মানে নোটসে যেটা আছে স্যার ওটা তো শুধুমাত্র এনার্জি কনভার্সন। স্যার এটা কি লিখছেন? I do D2 Oh, sir, is this deuterium an isotope?
Yes.
Sir, is it necessary that only this deuterium is used for nuclear reactions?
স্যার আপনি লেট স্পেসিফিক হিট অফ ইউরেনিয়াম বলছিলেন স্যার।
বুঝি নাই।
মানে স্যার আপনি এটা একটু বেশি আরেকটু বলছিলেন স্যার, ওই যে ওটা গ্যাস হয় না কেন মানে অনেক কিছু।
ওটা স্পেসিফিক ক্যাপাসিটি বেশি।
স্যার এটা কি ড্রিঙ্কেবল?
Definitely.
Okay.
It is drinkable, but it is hazardous. I mean, can you drink it? Yes. Will you live after that? I cannot guarantee. Something like that. I shouldn't have said that, but you get my point.
Sir, how is this deuterium formed?
Do you guys understand the difference between poisonous and venomous?
Venomous means there is pure poison in it, and hazardous means
No. Poisonous and venomous. What's the difference between these?
Poisonous means deliberately poison. Oh, no. I mean, no. Poisonous means unintentionally poison, and
Sir,
venomous means.
please, can you say it? ওর কথা শেষ হবে না।
Venomous means something, if that bites you, you'll die. Poisonous means if you bite that, you'll die.
What's the difference, sir?
Butcher.
Sir is high again.
Snakes are bad snakes are usually venomous. Not all snakes are venomous, whereas certain fruits and then let's say potka fish. Potka fish English name ki? Puffer fish. They are poisonous. They're not venomous. If they bite you, you will not die. But if you bite them, you will die.
Sir, are we done with today's class?
We can call it a day.
স্যার স্যার একটু কথা ছিল স্যার
বলো
স্যার ইউটিউবে স্যার আপনি 15 মিনিটের বেশি ভিডিও দিলেন কেমনে
দেওয়া যায় না
না স্যার আমি চেষ্টা করছি হচ্ছে না লেখা যাচ্ছে 15 মেসেজ দ্য ইউটিউব লিমিট এরকম লেখা আসে
কি বলো
হ্যাঁ হ্যাঁ এটা তো হয় যারা মানে না যাদের সাবস্ক্রাইবার কম
হোয়াট সাবস্ক্রাইবার কমার বেশির উপরে কি আছে আমি তো ইউটিউব চ্যানেল অনই করছি হচ্ছে কয়েকদিন আগে
অথবা যারা ফিক অথবা রেগুলার না হইতে পারে
না প্রতিদিন ছাড়া ভিডিও
স্যার আপনি কি এরকম কোনো আই মিন স্পেশাল প্যাকেজ এরকম কোনো কিছু মানে কিনেছেন
না আই এম জাস্ট এ ভেরি বেসিক ইউটিউব ইউজার
জাস্ট ওপেন করে ছাড়ি দিবেন
স্যার আপনার সাবস্ক্রাইবার তো প্রায় 300 এর মতো
আমার এত সাবস্ক্রাইবার হইছে
কম
একটু
নাকি
দেখেন তো
ইয়াসির তোরটা কত
63 মনে হয় আস্তে আস্তে বাড়তেছে
350 সাবস্ক্রাইবার্স
350 সাবস্ক্রাইবার্স ও মাই গড
স্যার
আপনার স্টুডেন্টরা কত ভালো দেখছেন
হ্যাঁ
ওটা আমার চ্যানেল না আরেকজনের
আপনার স্টুডেন্টরা কত ভালো দেখছেন
স্যার আপনি প্রত্যেকটা ভিডিওর শেষে বলে রাখেন লাইক শেয়ার এন্ড সাবস্ক্রাইব
না আচ্ছা শোনো বলবান তোমাদেরকে দরকারি কথা বলি আসি কি বার
স্যার শুক্রবার
শুক্রবার
এরপরে ক্লাস কবে
সানডে
সানডেতে আচ্ছা সানডেতে আমি পেপার 4 এর কিছু প্রবলেম দেখাবো তোমরা এর মধ্যে এই রেডিটিভিটি ওয়ার্কশিটে যতটুকু পারো অ্যাটেম্প করো ফার্দার কোথাও আটকাইলে আমাকে সানডে পরের যে ক্লাসটা আছে মনে হয় টিউসডে না পরের ক্লাস
জি স্যার
টিউসডে না মক শুরু করবেন
আচ্ছা মকের রুটিন এখনো করি না মকের রুটিন তোমাদেরকে দিব আগে আমি এগুলো একটু গুছাই নেই P4টা তোমাদের হাতে হ্যান্ডওভার করে নেই তারপর মকের রুটিন দিব মানে টপিক টেস্টের রুটিন দিব তোমাদেরকে ডোন্ট ওয়ারি
ওকে
ওই যে সাবজেক্ট যেটা বলছিল আমি ওই জিনিসটা করব সেটা হচ্ছে যে এক উইকে যেটা রিভিশন নিব তারপরের উইকে ওটা টেস্ট নিব দ্যাট ওয়ে ইট উইল বি ইজিয়ার ফর ইউ টু re-encapsulate the মানে earlier chapters so এটা easier হবে I really like that proposition so we'll go for that we'll definitely go for that আমি ওই রুটিনটা করার চেষ্টা করছি ঠিক আছে
স্যার রিভিশন ক্লাসের কি কোনো রেকর্ডিং থাকবে
সবকিছু রেকর্ডিং থাকবে
ওকে স্যার
I do online classes I'll do recording and they'll be uploaded periodically Allah Hafiz good night
স্যার
বলো
গুড নাইট স্যার
একটু প্রাইভেট মেসেজ দেখতে পারবেন মেসেঞ্জারে একটু ইম্পর্টেন্ট কথা ছিল
আচ্ছা ঠিক আছে আসতেছি আমি
আচ্ছা স্যার আপনি মেসেঞ্জারের কোশ্চেনস গুলো রিপ্লাই দিচ্ছিলেন না যে
I took a break from the world